Hi everybody, so today we're looking at 2013 question for C, okay, and we're asking this question to figure out how many neutrons are present in 0.14 grams of the carbon-14 element. Okay, now generally I would class this as subatomic calculations, but in this case, whenever you're asked to figure out the subatomic particles, any of them really, particularly neutrons though, in something in terms of grams, okay, then it becomes a little bit trickier. Okay, so we have to be careful there with what we were actually asked. Okay, so first off there, okay, if we want to figure out what the number of neutrons are, okay, we need to break it down to 14 grams, 0.14 grams of carbon. It's no good. Okay, so we're going to write out carbon again over here. So carbon, if we look at the periodic table, we'll have our 6 and we have our 14 over here. Okay, now it's nice up. Okay, so that's why it's 14 is there. Normally it's 12. That's okay. And 6 equals the what's the one I'm looking for? The atomic number, which is the number of protons. Okay, and the 14 equals the mass number, which is the number of protons plus number of neutrons. Okay, so that's grand if we want to figure out the number of neutrons. Therefore, we use our normal formula there. Okay, so the number of neutrons equals the mass number minus the number of protons. Okay, so that's grand. We'll plug in our information there. So number of neutrons equals our mass number is 14 minus 6, and therefore we're left with 8 neutrons. Now, we must be careful here. That is 8 neutrons per atom. Okay, so that's critical there, guys, okay? Because we're not dealing with one atom. Okay, in this case here, we're dealing with multiple atoms. Okay, many atoms. Because you're told that there's 0.14 grams. Okay, so therefore we have to figure out now how many atoms are present in carbon in 0.14 grams. Okay, so there's another formula we can use, and that formula is using Avogadro's number. So Avogadro's number is 6 times 10 to the power 23, so let's figure it out. So the number of atoms equals the number of moles times Avogadro's number. Okay, so if we do that out, we're obviously going to be missing a few bits. Okay, we're looking for the number of atoms, that's fine. We don't know what the number of moles is. We do know what Avogadro's number is, 6 times 10 to the power 23. So now we have to figure out what the number of moles is. Okay, so it's becoming a little bit trickier. So we go back to our formula there, number of moles. I'm just going to do a little side down here, guys. So number of moles equals mass over mR. Okay, and we're dealing with number of moles now of carbon. Okay. Okay, so now we have to figure out the number of moles. So let's just do that out. We're told the grams already, so we're told up here it's 0.14 grams of carbon-14. Okay, so we just go over here and say 0.14 here. Grand. Now, we have to put that over mR, okay, and if you get mR, we have it down over here, the molecular mass is going to be 14. So 0.14 divided by 14. So we're dealing with 0.01 moles of carbon. Okay, 0.01 moles of carbon. So we're going to plug that back up here. So it's going to become 0.01 multiplied by 6 times 10 to the power 23. And again, put everything in brackets. Okay, all together. Because you'll make a mistake if you don't. So when I do that into my calculator, so I've got the number of atoms equals 6 times 10 to the power 21. Okay. Now, we're actually not finished. We now know the number of atoms. That's grand. Okay. And we know that there's 8 neutrons per atom. So we want to figure out the total number of neutrons. Okay. So to it's going to, the total number of neutrons then would have to be 6 times 10 to the power 21 multiplied by 8. Because if there's 8 neutrons per atom, and this is our number of atoms, therefore this is going to be the total number of neutrons. And when you multiply the two together, okay, you're going to get 4.8 times 10 to the power 22 neutrons. And that is our answer. So there was a bit involved in that. Let's just start from the beginning again to have a quick look at it. We're asked for the number of neutrons. Okay, so again, I just wrote this down as a to help us along. You don't need to, but we know our number of neutrons is the mass number minus number of protons. So I did the 14 here, which is the mass number, taking away 6. So therefore we have 8 neutrons. Okay, but you had to be cute and realize there that was 8 neutrons per atom, and there's no way 0.14 grams of carbon contains only one atom. Okay, it's going to contain many. So we had to figure out the number of atoms. So I put this into my formula over here, and as soon as I did that, I realized I didn't have the number of moles. So I had to find out the number of moles. Mass over MR, standard enough. Okay, which we had. And I plugged this over here, and I got my number of atoms, which was great. Okay, now once I had my number of atoms, and I knew that there was 8 neutrons per atom, I multiplied the two together, and that gave us our total. And that's it, guys. Okay, so again, there was a bit involved in that, but it was manageable. It's not really difficult maths. You just have to figure out what formulas needed to use and how to get from A to B to C, essentially. Okay, guys, all the best with this.